Okay, in this video, I explain how to manipulate string or characters in R. I demonstrate basic convenient commands one by one, okay? First of all, letters is a vector of lowercase alphabets in R, okay? And you can, of course, extract part of it. For example, from the 3rd to 7th elements of the vector letters are C, D, E, F, G. Now, letters in capital letters are 26 capital letter alphabets, and of course, again, you can extract part of it from the 10th to 15th elements, for example, or I mean, you can give any vector. It doesn't have to be consecutive. I can say from 1st, 3rd, 5th, and 3rd and 1st elements again, and that would give me A, C, E, C, A. Okay, and of course I can save vector of characters with a new name. For example, I can define a variable named v4, which is a vector of letters. For now, we don't have any variables saved in the workspace. Now we have v4, which is from A to J. Okay, now it's not just R. In many programming languages, string or characters are expressed with quotation symbols. Okay, for example, and I can say apple with double quotation marks. Yes, this is a character. Okay, characters. If I simply type apple, then R says there is no such variable. Okay, we have v4, but we don't have a variable named apple. For characters, for a string, okay, you should use double quotation marks to distinguish a variable name and a string. Okay, so let's define a new vector. Let's say the first component is apple, and then banana, coconut, donut, almond, and blueberry. I hope I spelled them correctly. Enter. Now we have v5 here. So v5 has been defined. It's a vector of 7 strings. Okay, I can use square brackets to extract, let's say, the third component of v5, which is a coconut. Now, for vector of strings, you can use same functions as for vectors of numbers. For example, I can use reverse function, which gives me a reverse or a vector of the elements in the reverse order. So from blueberry to apple, I can use the sort function, which sorts the elements in the alphabetical order from almond, apple, banana. I can use rank function, which gives ranks of each element of the vector in the alphabetical order. For example, apple should be the second in the alphabetical order, so it sets 2. And the rank of the banana should be the third place, okay, so it sets 3. Coconut should be 5th, donut should be 6th, almond comes first. So these are rankings of these elements. Now order seems similar to rank, but it's different, and this is a much more convenient function. I should explain this function order in some other time, okay, because it's a very convenient, very useful function. For now, I'll just explain it briefly. So what does order of v5 mean? So v5 again is the vector which looks like this. So basically, if you follow this order, you can order the elements in the alphabetical order. So it says, look at the fifth element, okay, that's almond. Look at the first element, apple, okay. Then look at the second element, banana. And then look at the sixth element, that's blueberry, okay. If you follow this order, you will get the alphabetical order of the elements. Fifth, first, second, sixth. So that's almond, apple, banana, and blueberry. So that's the order function. Okay, next let me explain how to put characters and numbers in one vector. So this is our v4 from A to J. This is our v5. I can simply combine them to make a longer vector using create function. So create C of v4 comma v5, that will give me a vector of A to J first and then apple to blueberry. We can combine more than two vectors. I can combine v4, v7, and from 1 to 7. Okay. Now I'm defining a new vector v6. Sorry, v4, v5, and from 1 to 7. There you go. We have v6, which has been newly defined. So let's look at it. So v6 is a vector from A to J, and then apple to blueberry, and then 1 to 7. So we can combine more than two vectors. Now notice that in this newly created vector, 1 to 7 are quoted by the double quotation symbols. So there are numbers and characters, but one vector cannot hold both types. Okay, so as soon as these 1 to 7 were originally numbers, but as soon as you put these with v4 and v5, these characters, in one same vector, these 1 to 7 become characters. That's why they are double quoted. For example, I can say v6 to, well, I'll explain this difference between types. Okay, let me first quickly mention this function length. So this function tells you the length of a vector, the number of components in that vector. So this vector v6 has 23 components. Okay, 1, 2, 3, 4. If you count, it has 23 elements, components. Now, let's look at from the 20th to the 22nd elements of v6. That's 4, 5, 6. Again, they are quoted. They are put inside double quotation symbols, so they are treated as characters. I can check that using type of function. Okay, what is the type of this 4, 5, 6? Okay, it says character. So this is 4, 5, 6 treated as characters, so I cannot sum them up. Because they are not numbers, they are just letters. Now, if I want to convert them into letters, I should use as as numeric. Okay, this function as numeric converts the letters into numbers. So we have only 4, 5, 6 without double quotation symbols. Now we can, so this one we can sum up. Okay, 4 plus 5 plus 6 are 15. The type of 4, 5, 6 is integer. Okay, they are integer numbers, but if you quote it, that's character. Now, if you want convert numbers into characters, you can use as character function, and that will give you 4, 5, and 6 surrounded by double quotation symbols. Now for characters, for strings, you can use many special characters like period, comma, question mark, exclamation mark. So let me show you. For example, I can say X is, it doesn't have to be just Apple or Naomi. Okay, I can use a period or even a space. I can say hello, comma, I am Naomi. Okay, you can use these special letters. You can also use tilde and slash. So for example, I can define a variable y as, let's say your computer has a folder named Dropbox, and within that folder you have another folder named class 2022, and in that folder you have a file named homework1.csv. Okay, in this way you can save a name of a whole path, okay, or file names or folder names in variables. Next, let me explain how to concatenate two strings of characters into one. Concatenation means combining more than two strings of characters into one. Okay, for that purpose, the function we use for that purpose is paste zero function. Okay, this function just combine. I have a character vector apple, and I have another character vector string banana, and I can combine them. So now I have one string vector, character vector, apple banana. So let me show you another example. Suppose I want to combine hello, comma, space, and I space am space, and Naomi period. Okay, here I have three strings, three sets of characters, and I can combine into one. Hello, I am Naomi. Okay, we can use this technique to make a path from folder names and file names. For example, I can combine okay, suppose this is the folder name, okay, and slash, and I have a file name homework1.r. Let's say this is an R file. Here I'm combining three sets of characters, a folder name and slash and file name. I use paste 0 function to combine them into one entire path. Okay? Now let's go back to our vector v4. Remember, v4 was alphabets from A to J. Suppose I want to combine them into one string. If I simply type paste 0 v4, nothing happens. Nothing happens. If I want to combine them, then I should use collapse option. Suppose I give just double quotations. Then I get one string from A to J combined. If I set collapse to be a space rather than nothing, then A to J are combined with space between each of them, okay, with spaces in between. If I use underbar, A to J are combined into one string with underbar. Of course, I can use X. Okay, so you need this collapse option to put all elements in one vector together. Now let me define v7 to be the first 10 alphabets in uppercase. So we have v4 and v7. I can use paste 0 for v4 and v7. Okay, then like corresponding components are put together, like A and capital A are combined, then B and capital B are combined, etc. This happens because v4 and v7 are of the same length. Okay, they have the same number of components. If I just so instead of v7, suppose I have just z. Okay? v4 had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. v4 had 7 components. Z is just one component. Then Z is pasted to each element of v4, so that we have AZ and then BZ up to JZ. I want to show another application, but before that, for that let me define another character vector. Let's say we have 6 people here: Ayumu, Kazuki T, Kazuki Y, Ken, Toshiki, and Junpei. Okay? Suppose we have a vector of 6 people's names. Now, I can use this paste 0 function to combine first dear and then people and then son. Dear and son are just characters, whereas people is a variable. Okay, here. So what is the result? Now I have dear Ayumu-san, dear Kazuki-san, dear Ken-san, etc. Let's add some space. So I can add one space after dear and another space before san, and I have like this: dear Ayumu-san, dear Kazuki T-san, and etc. And this is the application, one application of this paste 0 function. Now let me explain how to refer to part of a string of characters. Okay, for that purpose, let me define v8, which is just one word university. Okay, first of all, how many letters are there in university? To know that, I can use this function, number of characters function, n-char, and I can type university, double quoted. So the function returns 10, meaning there are 10 letters in the word university. Of course, we defined V8, so I can give V8 instead of university itself, and I should get the same answer. What happens? What would happen if a vector is given to this function? So let's say n-char V8, so that's, n-char people. Okay, people is Ayumu, Kazuki, and etc. It gives the number of letters of each component of the vector. For example, Ayumu has 5 letters. So it says 5. Next, Kazuki space T has 8 letters. Apparently, space is also counted as 1 letter. And Ken has 3 letters, so we have 3 here, and so on. Okay, this is number of characters of function. To extract part of a string, the function we use is substring function. For example, let's extract from university from the 4th to 7th letters, and we get verse. Okay, that's 4th to 7th components of the word university. Okay, of course it's the same even if we have V8 here, because V8 is just university. Let's say we want to extract the last 4 letters of the university. Last 4 letters. Of course we can count. Okay, there are 10 letters, so that should be from 7th to 10th. We can do that, but we can program it. Let's extract from university. The starting position is number of characters in the university minus 3, and the number of characters. Okay, that way we can get the last 4 letters of the university. Let's break it down. Number of V8, well, number of characters in V8 is obviously 10. And if we extract 3 from 10, we have 7. So we have 7 here and we have 10 here. And this is how we get from the 7th to 10th components, from the 7th to 10th letters in university. This is very useful. For example, suppose from the people vector, suppose I want to extract the last 3 letters of each name. Okay? Then I can say substring people. Well, first 3 letters are easy, right? The first 3 letters of Ayumu should be Ayu, and the first 3 letters of Kazuki should be Kazu. But if I want to have the last 3 letters of each name, then what? I should have like this. Okay, you should understand what's going on here. So this gives the number of letters. So this is, so the number of letters. Ayumu has 5 letters in it. Kazuki T has 8 letters in it, including space. And if I extract 2 from that. Okay, that's 3, 6, 6, 1, 5, 4, and so on. So this command gives me from the 3rd to 5th letters of Ayumu and from the 6th to 8th letters in Kazuki T and so on. That's how we got this. Alright, let me explain how to search for letters in strings. Again, people is a vector that looks like this. We use grep function for searching. So let's search for ki, key, in the vector people. It returns 2, 3, and 5. This means that out of the vector people, the 2nd, 3rd, and 5th components should contain key. Let's look at it. Ayumu doesn't have a key, but the Kazuki T and Kazuki Y have key, so that's 2nd and 3rd component. And the 5th component, Toshiki, also has key. Okay, so this is correct. This is correct. It says the 2nd and 3rd and 5th components should have key. Now, if we want the function to return these component itself rather than just indices, we use the option value. We set option value to be true, and we get, well, instead of just 2nd and 3rd and 5th components, the function sets Kazuki T, Kazuki Y, and Toshiki have ki. Okay, this is how to search letters in strings. Finally, let me explain how to make random draws from strings. Now, for that purpose, let me explain how to draw integers. So this sample function is a convenient function. For example, I can extract 20 numbers from 1 to 75 without repetition. Okay, sample 1 to 75, 20, and replace equal follows. This draws 20 integers from 1 to 75 without any repetition. Okay, so there should be 20 numbers here, randomly drawn, 53, 66. It's like a bingo game. You can draw the same numbers again and again. For example, I can set sample 1 to 6, sample from 1 to 6, 20 numbers with replace true. Then it's like rolling a dice again and again 20 times. 3, 1, 3, 6, 2, 2, 1, 6. There should be 20 draws. Okay? Now we are going to use this function to make a random draw from strings. The trick is easy. Some of you might have already detected what's coming. For example, I can make a vector named coin, which is a string vector of head and tail. Okay, the first component of coin is head. The second component of coin is tail. First, second, and again first component of coin are head, head, and tail, and head. So using this, I can first randomly draw integers using sample function. So out of 1 and 2, with allowing repetition, I can draw 20 numbers, 20 draws. So for example, x1 looks like this: 1, 2, 1, 1, 1, 2, 1, 2, 1, 1, 2, 2, 1, 1, and so on. And then I can give this vector into the vector coin x1. Then I should get first component of coin, that's head, and then second component of coin, which is tail, and z, and etc. And this looks like I tossed coins 20 times. Now for this sampler function, you can actually change the probabilities as well. So for example, so this is another option. So I can set up a probability. If I don't set up this, if I don't set this up, then 1 and 2 will be shown with equal probabilities, 50-50, but I can instead give a specific probabilities like 0.8 and 0.2. Okay? Then in x2, 1 is drawn with probability 0.8 and 2 is drawn with probability 0.2. So 1 is more frequent, as you can see. And I can give this to the coin vector, and this time we see head more frequently than tail. Okay? Finally, there is a function unique which gives you a list of unique components in a vector. Okay? For example, this vector has repetition. Head appears many times, tail appears many times also. But unique components are just two, tail and head. And this function is useful when you have a long vector of names, words, and you don't know whether there are repetitions. You can use unique, and you can extract unique components. Each component appears only once in this. Okay?